Hello, everyone, and welcome to our Math 112 final exam review session. I will be dropping a packet into the chat, and if you can take just a couple of minutes and look over that packet and see which questions you would like to ask. We'll get started in just a minute or two. Okay, so in this packet, if you have questions or you'd like to see them worked, feel free to either speak out your question or to drop it in the chat, and I will let our math person know. So without further ado.
All right. All right, yeah, so like Dr. Blue said, if you have any questions, we're going to kind of go through this page by page. Feel free to shout it out. If we go past the page, you want to go back, let us know, and we can handle that. So let's look at page 1, or page 2, I guess. Are there any questions on page 2? All right, if there are no questions on page 2, let's look at page 3. All right, 7.1, systems of linear equations in 3 variables. Let's look at page number 4, where it's talking about systems of linear equations and solving.
Please.
16. Uh-oh. Oh, is it been? There we go, 16. Can do that. All right, so this one says use left to right elimination to solve the systems of equations. So in this case, what we want to do is solve for, oh my goodness, x, y, and z, right? So I'm going to go ahead and rewrite our equation. X minus 3y plus 4z equals 7. 2x plus 2y minus 3z equals -3, and x minus 3y plus z equals -2. So this says use left to right elimination. I'm actually going to use substitution because I think that's easier and it's easier to do. And what that means is, like when we have 2 systems of equations, we just want to solve for like either x, y, or z, and then plug that in. So in this case, let's solve for z first. In this bottom equation here, we see that z is already by itself. If we just subtract x and add 3y to both sides, that'll end up giving us z is equal to -2. We're just going to look at one equation at a time right now as well. Plus 3y. Actually, hold on. My fault. Before we do that, we're gonna look at the 2 equations. So let's look at the bottom 2. And we notice if we wanted to get rid of the x's, we can multiply this entire bottom equation by 2. And this will make more sense here in a second. When we have, so if we multiply that whole equation by 2, we have, so the top equation doesn't change. 2x plus 2y minus 3z is equal to -3. And the bottom equation will be 2x minus 6y plus 2z equals -4. And if we subtract these equations, our x's will cancel. We'll have 2y minus -6y, which is going to be 8y, because minus and negative is positive. 3z minus 2z, which is minus 5z, is equal to -3 minus -4, which is 1. So in this case, let's just solve for z. So z, to do that, we have to subtract 8y on both sides. We get -5z is equal to 1 minus 8y and divide by -5 on both sides. So in this case, z is equal to 1 minus 8y over -5. We can plug this into the equation that we didn't use. So we used these two equations here, which means we can put it back into this top equation. And we'll be left with x minus 3y plus 4 times the 1 minus 8y over -5 equals 7. Now, I know this equation is a lot of work, but for right now, when we have to solve this by hand, this is my recommended way, because it at least makes more sense to me. So then we can kind of simplify this out. We have, I'm going to kind of work down into here, x minus 3y plus 4 times the top. So what I'm actually going to do is if we multiply 4 here, that's the same as 4 times 1 minus 8y. So we can just distribute it to the top, right? So we just have 4 minus 8 times 4, which is 32y over that -5 equals 7. Now we want to combine like terms to get just x and y. So we're going to have, let's see, that's going to turn into a gross number. X minus 3y. I'm just going to go ahead and do this in a couple different steps. We have minus 4/5 plus 32y, 32/5 y equals 7. Because what I'm doing is just moving that -5 to both of them. We can kind of separate them out. And so we know we have, how do I get that calculated back? So right here, no, that was not it. So
Calculator.
yeah.
Okay, on the bottom, pull it up, grab the calculator.
Oh no. I forgot how to do this. Sorry, technical difficulties.
Adjust.
All right, there we go. So we have -3 plus 32 over 5. And we can turn that into a fraction, which is 17/5. Wow, really gross. So we really have x plus 17/5 y minus 4/5. But instead of that, I'm just going to go ahead and add 4/5 on both sides. Plus 4/5. And most of these that you will do won't be this gross, by the way. So we're adding 4/5. So 7 plus 4/5, which is 0.8, is 39/5. 9 over 5. Okay, so now we can lastly solve for, or not lastly, but we can solve for either x or y, but in this case, we want to solve for y because we already have z in terms of y. So to make this even grosser than we already have, we subtract x on both sides. We have 17, 5, y equals 39 over 5 minus x multiplied by 5 on both sides. So we have 17, so times both sides times 5, 17y equals 39 minus 5x. Divide by 17, y is equal to 39 17ths minus 5 over 17ths x. We're almost there, I promise. And this is going to be a little bit more gross algebra, but like I said, the equations you'll probably have on your exam won't be this bad. And I'm actually going to kind of pull this next part into a new sticky note here. See if I can get that scaled right. All right. So then we want to plug this y back to find our z. So we really have z is equal to 1 minus 8 of 39. Hold on. Let's think something here. Hold on. 1 second. We want to plug y. Oh, I know what I did wrong. We wanted to solve for x. That way we can get all the y's. Because this is turned into gross math. All right. Let's see, where did I go wrong here? You know what? I might say we'll come back to this one because we're going to go through this and there's going to be a little bit easier of a way to solve this, and that'll count for your problem if you see it. So sorry about that, but you know, the steps we're going to take is solve for z, or solve for one of the variables, plug it back in, get it in terms of one more variable, plug it in again, and then we'll start getting answers like x is equal to 7 or something. And then you can plug that in to, so like, for example, let's say we got y equals 5. We could then plug that into our z, find the z, get like z equals 2, plug that in for x, and then we get x equals 3 or something like that. Yeah, my apologies for that one. It was getting a bit gross and probably more confusing than it was helpful, because we started getting to all the fractional algebra and stuff. So let's go through and we'll start talking about more matrices and row reduction. If you all remember echelon form, and that'll actually help you all out with this as well. So sorry about that. Yes, okay. Let's look at page 5. Like I said, we'll end up coming more equations. I don't have to answer that question. So make sure when I see that section, I'll make sure to go over a problem. All right, let's look at page 5, 17 through 25. They're going to do the same thing as this one. So go ahead and look at page 6. Any questions there?
Like we're good.
All right, page 7. This is kind of where I was going through with this, but for the first part, it's talking about augmented matrices. So any questions on getting a system of equations into a matrix? All right, if there's no questions on page 7, let's look at page 8. And if we don't have any questions on page 8, I'll pick one and we can go through it. That way we can replace the one that I was struggling with earlier. Let's look at 15 here. So first off, when we have the system of equations and we want to use the Gauss-Jordan method, our row reduction, we can do this in our calculator, but our goal is to go from our matrix to get a diagonal of ones and a bunch of zeros and then whatever numbers here, right? So this is our goal to get. And to do that, we're going to do what's called Gauss-Jordan elimination. So let's turn this matrix into this system of equations into a matrix. So we're looking at all the coefficients. The first equation is, I'm going to make that a little bigger. 1, 1, -1, 0. Then we have 1, -2, -1, 6. We have 2, 2, 1, 3. All right, so like I said, our goal needs to be to get that, I think it was up here. Yeah, pretty much to get something that looks like this. The 1, 1 on the ones on the diagonal. So to do that, we can use one of the rows to manipulate the other rows. So this first step, let's go ahead and get all of our, we're going to pretty much take this similar to left to right and get this whole column as what we want to have. Oh gosh. So in this case, we want to, if we subtract the first row, so we do row 1 minus row 2, that would equal row 2. And we know 1 minus 1 here is going to give us 0. So I'll turn that first term to 0. And if we do row 1 minus 2 times row 3, or sorry, 2 times row 1 minus row 3 is going to give us row 3, which will turn that to 0. I'm going to go ahead and add a sticky note here. That way we can just kind of write over these. All right, so let's do both those operations. So we know 1, let's do this first operation here. Row 1, well, the row 1 is going to stay the same. We're not doing anything to row 1. Row 2, we're subtracting row 1 minus row 2. So 1 minus 1, 0. 1 minus -2, well, anything minus a negative is going to be positive. So that'd be 3. -1 minus 1, that'll be, or -1 minus -1, that'll be 0. And 0 minus 6 is going to be -6. Let's look at the row 3 operation. So if we do 2 times row 1, so I'm going to kind of write that out up top here. If we had 2 times row 1, row 1 would equal 2 times 2 times -2, 0, minus row 3, which is 2, 2, 1, 3. So we'll end up getting 0, 0, -3, -3. So that'll be our row 3. And that's the same thing we did with row 2. We just didn't multiply it first by anything. And now, as you can see, we're getting somewhat close to where we need to be. We've got a bunch of zeros starting to pop up. Well, to get this row 2, this number right here needs to be a 1. So we need to take 1/3 times row 3. We're just pretty much dividing row 3 by 3, so that'll turn into 1. So if we divide row 3 or row 2 by 3, sorry, I kept saying row 3, we'll get 1, 1, -1, 0, because that's not changing. Row 3 isn't changing. But however, this row, we want to divide by 3. Well, 0 divided by 3 is 0. 3 divided by 3 is 1. 0 divided by 3 is 0. -6 divided by 3 is -2. So we just basically divided that whole row by 3. And now we need to get this column all zeros except for that one in the middle. So we need to do row 2 minus row 1 to get row 1. Because this right here needs to be 0. And we know 1 minus 1 is going to be 0. So if we set that up, we'll end up getting, so 0 minus 1 is 1. Or, yeah, 0 minus 1 is 1. That's going to retain that 1. Then this is going to be 0. That'll still be -3. We didn't do anything to the bottom row. That's going to stay the same. That's going to stay the same. So we have this row 2 minus row 1, 0 minus -1. Well, that's still going to be, no, that'll end up being a +1, I believe. 0 minus -1. And then -2 minus 0 is just going to be -2. And my simple math is not working with me today. So we now have this, and we want our last one to be here. We have -3, -3, we want that to be 1. So we need to do row 3 divided by that -3. That'll give us our 1, 0, 0. Our second row and our first row did not change. That'll end up being 1 now. That'll also be 1. So now we just need to subtract row 3 minus row 1 to get row 1. So we have 1 minus 1. Everything else is going to stay the same. So that's where the 1 minus 1 comes in. Our bottom row stays the same. Our middle row stays the same. Then we have 1 minus -2, which would be 3. So our answers, we'd interpret this as our x, our y, and our z. Or I like to write x, y, and z over here. So x is equal to 3, y is equal to -2, and z is equal to 1. It will be on your test, most likely, to know how to do one of these by hand. It does take a lot of work, as we just kind of went through, but we can check our answers in the calculator. So if we wanted to check our answer to this in the calculator, we would take our original augmented matrix. So we go to second x to the -1, which is matrix right here. We will go over to edit and create our matrix. Matrix A, so we know this is a 3 by 4, the 3 by 4 matrix, and we want to fill this out. 1, 1, -1, 0. Then we have 1, -2, -1, 6. We have 0, 0, -3, -3. Or sorry, I looked at the wrong matrix. It is actually 2, 2, 1, 3. Because this is the matrix we started with here. Right here. And then from there, so we built our matrix. So we go to second, we quit out, go back to our matrix, and now we notice that matrix A is full of values. We can go over to math and scroll down to RREF, which stands for that reduced row echelon form. And then we can bring in our matrix A and press enter. As you can see, our answers here, 3, -2, 1, which is what we had. So we know we did it right. And that's the same way, and we can apply that same method back up to this one up here. So we can kind of scratch out all that work right here and apply the same method we just did. That's why I said we'll take a break.
That's also a way to do it.
Yeah, that's left, yeah. All right,
What do you have?
For the top right one,
top right here.
you divided, you divided row 2 by,
I divided row 2 by 3. I can kind of,
why did you divide by?
because we want that middle portion right there. This one that I circled, we need that to be 1. That way we can have our identity matrix down here of just the ones.
So say if it was like 6 there, you divide by 6.
Yeah. Yeah, the 6 you divide by 6. Whatever makes that term 1 is what we're going to divide by. All right. Any more questions on that one? All right, let's look at page 9 here. Any questions on page 9? All right. 7.3 matrix operations. Any questions on page 10? Which is all about addition, subtraction, and multiplication of matrices. All right, what about page 11? And we're doing matrix multiplication. I will say it'll be good to know how to do one of these by hand, but we can use our calculator to check our answer. Row by column. Yep.
Number 11, please.
Number 11. Cute. D and E and E and D. So let's sticking out here. We're going to need D and E. Let's go and write out D, which is equal to 2, 3, 2, 3, 4, 5, 1, -1, 1, and E, which is equal to 9, -5, 7, 2, 0, -4, -7, 5, -1. All right. For this one, oh, I hope that doesn't stretch. Oh, that did not work the way I wanted to. Screw that one. For this one, we want to find D and E and E and D, and what's the name of 1/10 D. So first, let's find DE by hand. So we want to find DE. So we need to make sure, first of all, we can multiply these. So D is a 3 by 3, and E is a 3 by 3. So these middle numbers here are the same, which means we can multiply them. And our resulting matrix is going to be this 3 by 3 here. So let's write out a 3 by 3. I'm going to make it kind of big, so we're going to have to write out a lot of numbers. All right, so D times E. That means we want to take a row of D times a column of E. If we want to find this value right here, that is our first row, first column. So first row, first column, we're going to have to multiply this first row by the first column. So 2 times 9, so the first value of each one is 18, plus, so we're going to add whatever our result is. We have 3 times -5, negative 15. So plus negative 15 plus 7 times, or 1 times 7, that is going to be 7. That is our first row, first column. Now, if we want to find our first row, second column, we're going to do that first row by this second column. So 2 times 2 is 4, plus 0 times 3 is 0, plus 1 times negative 4 is negative 4. Then lastly, to find the end of this first column, let's spread that out a little more. We have that first column times the third column, right? Because that's the value we want to find over here. So we have negative 7 times 2, which is negative 14, plus 3 times 5, which is 15, plus 1 times negative 1, which is negative 1. Now, we need to do our second column. Just didn't need to do that. 1. So we're trying to do our second column. So second row, first column is going to be this value, second row, first column. So we have 3 times 9, which is 27, plus 4 times negative 5 is negative 20, plus 7 times negative 1, which is just negative 7. All right, let's look at second row, second column here. So we have 3 times 4, or 3 times 2, which is 6, 0 times 4, so plus 0, plus negative 1 times negative 4, which is just 4. Let's find that second row, third column. We have negative 7 times 3, which is negative 21. Let's slide this calculator out of the way. There, a little nicer workspace. So, and then we have 4 times 5, so plus 20, plus negative 1 times negative 1, which is just 1. Now, we want to find the third row. So, third row, sorry. Third row times first column, which is 18 plus, that's negative 5 times negative 5, or negative 5 times 5, negative 25, plus 7 times 1, which is 7. And we do third row times second column, which is 2 times 2, which is 4, plus 0 times 5, which is 0, plus 1 times 4, which is negative 4. And lastly, third row, third column, we have 2 times negative 7 is negative 14, plus 5 times 5 is 25, plus, 7, 25, plus negative 1. All right. So we get, if we calculate this, DE is equal to 18 plus negative 15 plus 7, that'll be 10. 4 plus negative 4, 0, 0. So we're just adding up all these columns, or all these that we found. 27 plus negative 20 plus negative 7 is going to be 0. 6 plus 4 is 10. Negative 21 plus 20 plus 1 is going to be 0. 18 plus negative 25 plus 7, 0. 4 plus negative 4 is 0. 14 plus 25 plus negative 1 is 10. All right, so that is our answer for D, D, E. We want to check our answer. Again, we can do that in our calculator. But since it also tells us to calculate ED, let's see that. There we go. It also tells us to calculate ED. We'll do that one in the calculator. So we're going to have to create 2 matrices. So matrix, we'll we'll pick D and E just for this part. They're both 3 by 3s. And this D is 2, 3, 1, 3, 4, -1, 2, 5, 1. So we're just going to the same place and kind of inputting the matrices the same way we did for the problem earlier. So we have 2 3 by 3s, which is 9, 2, -7, -5, 0, 5, 7, 4. Oh, that's not. That's 7, -4, -1. Double check, right? That's a 0. And then that is a 5. All right, we've put in our 2 matrices. So all we have to do is go back to the matrix. We can do D times E to check our answer. That's what we got. That row tens. Now, if we wanted to do D times or E times D, we just have to do that same thing. And so if we wanted to find E times D, well, they're not always going to be the same thing, but in this case, they were. So make sure we note that those will not always be the same. So part B asks, what is the name of 1/10 DE? So if we did 1/10 times DE, that means we're multiplying each of these values by 1/10. We're going to get 10 divided by 1 is 1. Anything 0, it's going to be 1. 0, 0, 1, which is just that same thing we kind of want when we have our reduced row echelon form. And the name of that, if we remember, is our identity matrix. So it just has those ones on the diagonal. Right down. All right, any more questions on that, on matrix multiplication? I know I blocked it up on the screen, I'm sorry, but I think Dr. Blue posted them in the chat if you need them. All right, let's look at page 12. Any questions on page 12? All right, if there are no questions on page 12, page 13. Any questions on page 13? All right, what about page 14, number 39? I guess, yeah, so just the rest of chapter 7. All right, then. Let's move on to chapter 8, sequences and discrete functions. Any questions on page 15?
For number 1, you plug in. For like.
Yeah.
First time you do 2 times 1 plus 3. First time.
For number 1 here? So yeah, if we wanted to find the first 6 terms, all we're gonna do is just plug in 1, plug in 2, plug in 3, 4, 5, and 6. And then we're just gonna solve. So we just plug in all those, and those are our first 6 terms. So For example, we plug in 1, we get 2 plus 3, it's 5, 2 times 2, which is 4 plus 3, 7, and etc.
We have a request for number 6.
Number 6, find the next 3 terms of the arithmetic sequence. So remember, our arithmetic sequence is when we're adding or subtracting something. So let's find out what we call the common difference is first. To take that, we do 2 terms. So let's take this second term and this first term, and we subtract the second minus the first. We did 5 minus 2. I guess I should put here, 5 minus 2 is 3. That's our common difference. So we know every term we need to add 3. So what we can really do, if we don't want to use the formula, which we technically are using the formula, but so we have 2, 5, 8. We know this next term is going to be 8 plus 3. That's 11. Plus 3, going to be 14. Plus 3 again, going to be 17. So these 11, 14, and 17 are our next 3 terms. And we're technically just applying this formula, but all we're doing is just adding that difference 3 times. Any more questions on page 15? Number 8.
Would you use that same formula for that?
So we have find the 40th term of the arithmetic sequence with first term 5 and common difference 15. Yeah, so let's look at this formula right here. These formulas will be given to you on your exam on a formula sheet, but they will not be labeled. So a quick little tip for those is remember our arithmetic sequences, we have a common difference, and our geometric sequences, we have common ratio. So if we're adding or subtracting something, we're going to use the common difference formulas. And if we're multiplying something, we're going to use the ratio formulas. So in this case, we want to find the 40th term. I'm going to go ahead and do it down here. So we want to find a sub 40. We're going to find the 40th term. We're just using this formula right here still. Is equal to A1, which is our first term, which in the problem, our first term it says is 5 right here. So first term 5 plus, well, n, that was 40, because that's our nth term, minus 1 times our common difference, which is stated as 15. So we can kind of plug that in our calculator. 5 times 40 minus 1 is 15. So our 40th term is just 590. Any more questions on page 15? These are good to know. All right, so page 16 then. Any questions on page 16? $15? All right. Find the first 4 terms of a sequence with first term 2 and the nth term a sub n is equal to 2, a n minus 1 plus 3. Find the first 4 terms of that sequence. We know our first term is 4, or is 2 right here, right? So I'm going to go ahead and create a sticky note. All right. So we know our first term, a1, is equal to 2, because that's what it tells us. And our nth term is equal to this formula right here. So we just want to find the first 4. So we want to find A2. Well, A2 is equal to 2 times an minus 1, which is A1, plus 3. So A2 is just equal to 2 times 2, that's not a 2, 2 times 2 plus 3. this case, that's 4 plus 3, which is 7. So our second term is 7. All right, let's look at our third term. A3 is equal to 2 times a n minus 1, so a2 plus 3. So a3 is equal to 2 times 7 plus 3, which is 14, plus 3, which is 17. Lastly, a4, all right, let's squeeze this in here. A4, that's a y. A4 is equal to 2 times a n minus 1, which is a3, plus 3. Did it again. A4 is equal to 2 times 17 plus 3, which is equal to 34 plus 3, which is 37. So A4 is 37. So that would be our first 4 terms. So we're just plugging in which A we want to find because it gives us the formula.
That minus 1 to 3.
So the n minus 1, so if we wanted to find A4, right? I'm not, maybe A3 because I can't seem to write it before. So we have 2 times A3 minus 1. So we're going to do that 3 minus 1, which is just A2. So all that's saying is just the previous term. So if it was like A of n minus 2, and we want to find A3, we'd need A3 minus 2 or A1, which is our first term. We're just plugging in whatever term it asks for. Yep. Any more questions on page 16? All right, let's go to page 17. Any questions on page 17 or the rest are all of 8.3? All right, there's nothing on page 17. What about 8.4? So page 18. Any questions? Finite series. Number 13. All right. So we have sticky notes. All right. We have the summation from I equals 1 to I. So 1 to 6 there. So what's really happening is we're just adding 2 to the 1 because we start at 1. That's what tells us we start at 1. And we're plugging in I every time. 2 plus 2 to the 2, plus 2 to the 3, plus 2 to the 4, plus 2 to the 5. That's just 5. Plus 2 to the 5, plus 2 to the 6. So really, we just go from this number and add up all the way until we get to that number. So in this case, we can just plug that in our calculator. So we have 2 plus 4 plus 8 plus 16 plus 32 plus 64, which I believe, I'm not going to try and do that in my head, plus 4 plus 8 plus 16 plus 32 plus 64. 126. That would be our answer. But I also want to point out, some calculators allow you, a lot of the TI-84s you can plug it into. Some of the TI-83s you can't, sadly. But if you do have a TI-84, what you can do is you can go to Math and scroll down to where it says Summation, and it'll kind of create that same summation. And so we can plug in I, so alpha I from 1 to 6 of 2 to the power of that I. That's a square root. 2 to the power of I. And it gives us that same answer. So some calculators allow you to do that, some don't. I would recommend knowing what is actually happening though. But you can use your calculator to double check yourself. Any questions on that one? No more questions on that one. We can look at page 19. Any questions on page 19? One? 1 and 10? So they're pretty much asking the same thing. So is there one you'd rather go over? They're going to do the same.
Oh. First.
All right, let's look at number 1. So find the sum of the first 6 terms of the geometric sequence 9, 3, 1, etc. So we need to find first what our ratio is. Our ratio is going to be that second term, so A2 divided by A1. That's our ratio. So in this case, that's 3 divided by 9, or 1/3. And we're going to be given that formula on that formula sheet, like I mentioned, S sub n, so the sum of n terms, is equal to that formula. So we know S sub n, so we want to find S of S for the first 6 terms. S sub 6 is equal to A1, well, our first term is 9, times 1 minus the ratio to the nth power, so 6th power, over 1 minus that ratio. So we can kind of plug that in your calculator. We get 9, 1 minus 1/3. I always recommend making it look like how it looks like on the paper. 6. Six. All right, times 1 minus 1/3. That's going to give us 13.4814, etc. So that's going to be what our answer is. Make sure we put it in correctly. We followed our formula. R didn't equal 1. So it's going to be 13.481. I always recommend rounding to 4. So 13.4815. That would be our sum. Or if maybe we can turn to a fraction, same as 364 over 27. Any questions there? So for number 10, you're just going to follow that same thing, except n would be 15, and your ratio is going to be, I guess, 1/2. Same steps. Number 5 here. Yeah, for sure. All right, so this one says find the sum of the first 15 terms of the arithmetic sequence. So that's the difference here. So notice this one has our ratio like we talked about, and this one has a difference. So find the sum of the first 15 terms of the arithmetic sequence. So first term, -4. So we know A1 is -4. And AN, that's going to be, remember our formula way back up, where is that? Up here. So AN is first term plus n minus 1 times D. So we want to find the 15th term, right? So A15, because for our formula here, we're going to need that A sub n. So A15 is equal to A1, which is at -4, plus n minus 1, so 15 minus 1, which is 14, times our common difference of 2. So that'd be 18 minus 4 is equal to 14. All right. So now if we want to find our sum, so sum of 15 is equal to 15 times our first term, which is -4, plus our last term, 14 over 2. So we can plug that in our calculator. We have 15 times -4 plus 14, that's 44, over 2. And our sum is equal to 75. And there we go. So it's just going to be applying those formulas. And like I said, anytime you see a ratio, you're dealing with geometric sequence because your formulas will not be labeled for you. By doing our other formula, which is our A sub n is equal to A sub 1 plus n minus 1 times our common difference. Yep, so I found A sub 15 and A sub 1, and that's what we need for this formula here. So we plugged A sub 1 and A sub 15. There we go. Any more questions on pages 18 and 19? Any more questions on those? Any questions through the rest of the packet, page 20? Or if you have any questions from previous chapters, let us know. This is going to be kind of a, if you have any questions at all, anything about your exam or stuff like that. Their exam's 3:30 to 5:30 on Tuesday.
Sounds reasonable.
I think that's what it is. It's either 3 to 5, 3:30 to 5:30 on Tuesday. And I'll give a quick shout out saying the tutoring center will also be open this week, same hours. We'll be a little less staffed.
Request for number 39.
Number 39,
I knew it.
annuities. Okay.
Oh, and what chapters will the exam be over?
The exam, the final, I believe, should be over, what, 6 to 8?
Yes, that's my understanding.
Yes. So find the 8-year future value of an annuity with contribution of $100 at the end of each month. Pays 12% per year compounded monthly. Do I have that formula here?
So the finals are not comprehensive, they're just over the second half.
I think they are. Because this is only chapter 7 and 8, I believe. They should cover everything you took on your midterm and then everything you've learned from your midterm now. So they should be comprehensive. Yep. Find the 8-year future value of an annuity with contribution of $100 at the end of each month with an account that pays 12% per year compounded monthly. I do not have that formula sheet with me.
I've got it on.
Yeah, you can just tell me the formula and I can write it down. I think so. Annuity formula.
So, there it is.
So we have the formula for this, like I said, it'll be on your formula sheet, but you'll have to identify what it is. It's R1 plus R to the N, the NT. NT minus 1 over R to the N, where R is how much we're putting in. So R is the number we're putting in. So in this case, our R is $100 at the end of each month. To an account that pays little r, so big R is that annuity. Little r is 12%, so that's 0.12. N is how long or how much we're compounding. So on your formula sheet, this also might be K. I think it actually is K on your formula sheet. But for right now, we're going to use N. N is equal to monthly, which is 12. There are 12 months in a year, over 8 years. So T is our time, which is 8 years. And we're just going to plug all that in the calculator and make it look exactly like it looks here. So create our fraction, which is 100 times 1 plus, or another fraction, 0.12, 12, all to the n minus t, or n times t, which is 12, 8, minus 1 over other fraction is 0.12 divided by 12, which is, find the future value of our annuity. So that'd be $2,582.73. That's how we do that. So like I said, you'll get a formula sheet, but you will have to identify what the formulas are. And this will be on there. It's either going to be N or K as well. Not sure. Any more questions? There are no more questions. I'll once again say our tutoring center will be open normal hours this week. We'll have online appointments. We'll have in-person appointments. If you need to get help with look at old exams or anything else, we'll test prep or anything. We do that. So we're in Wallace 342. You need that as well.
Then I will drop links to those, to the math tutoring in the chat, just a second. Math tutoring. And then the STEM Center also has some tutoring this week. And let me drop that schedule in the chat as well.
We're just grabbing. All right, oh, you grabbing the QR codes for those here in person.
The websites too. Appreciate it. Sure.
All right, if there are no further questions, then we're going to go ahead and wrap this session up early. We appreciate the time you took to spend with us on this fine Mother's Day. And if you need help, reach out often, and we are here to assist all of your efforts. Thank you, everyone. You're welcome, Nick. All right, you're good. Cool.
Can you stop broadcasting?
Yes.